Welcome to solverfy.
So we find the flux using this equation. So flux is equal to integration over the dot product of magnetic field and the area. And in the xy plane, circular area, so xy plane, the circular area is given by pi r square, which is comes out to be 0.01327 meter square, and dA cap, because this is an xy plane, so the area should point in the z direction. Next we use equation 1.18 to calculate this scalar product. So for part A, the magnetic field is in the z direction, so we can write this as the magnitude and then direction given by k cap, and this means that B vector and dA are parallel because both point in the same direction. And we know that dot product is given by the magnitude of both the vectors times cosine of the angle between them. So when these two are parallel, as in the first case, phi is 0. So phi b will just be integration over the magnetic field times the section or a section of a small area. And since magnetic field is constant, we can take it out of the integration. So we are left with just this area, and the integration over the small area is the total area. So this is B times area. And we have the magnetic field and we found the area over here. So the flux in the first part will be 3.05 times 10 to the power minus 3 Weber. Similarly, for the second part, the vector B, so let's say this is the vector, the area vector which points in the z direction, and magnetic field makes an angle 53.1 degree with z. So B dot A will then be B times dA times cos phi, where phi is 53.1 degree in this case. So we will follow the same equation that we did for part A. So this one. So for this case, the integral will be b dA cos phi. And we see that b and cos phi are constants, so they come out of the integration and we are left with integration over the area. So that gives us the total area A times cos phi. And we solve this and we get this value of flux to be 1.83 times 10 to the power minus 3 Weber. For the last part, we see that the magnetic field is perpendicular to the z direction. This means that B dot dA is B dot dA cos phi, and phi is the angle here, so phi is 90 degree, and cos phi then becomes equal to 0 because cos 90 is 0. And so the flux, which is given by the integration over B dot dA, will be 0.